Welcome to my presentation video for the final assignment in music and audio programming. I've created a pitch-aware granular synthesis algorithm, which is then applied to a digital musical instrument using the Bella platform. As you can see, I've already loaded the Bella project into the web IDE, and I'm gonna go ahead and start the project now. And then I'm going to access the user interface I created in order to control all the system's parameters. So next, I want to give a brief explanation of the user interface. So first we have the source position slider, which converts these seconds value into samples to determine the position of the extraction window and sends that to Bella. Then we have the grain length slider, which just specifies the grain length globally for all grains in the range of 0 to 500. Then we have the number of grains per second slider, which specifies how many grains are played per voice per second. So if it's set to 1 and I play one voice, then I'm gonna have 1 grain playing per second. And I can bump that up all the way to 30. So if I then play 5 voices simultaneously, there's gonna be 150 grains coming out per second. The grain scatter slider adds some pseudo-random factor to the grain's lengths and starting positions, which allows the user to use this instrument as a kind of more experimental, more chaotic device, which is less deterministic in its behavior. And finally, the main output gain slider, which goes from 0 to 20. I've made it so that it goes to 20 because through the masking process of the voices or in the voices, a lot of frequency information is actually discarded depending on the frequency that's played. So it can happen, especially dependent on the source signal, it can happen that if I only play one voice, the output signal is low in amplitude. So that's why this slider goes all the way up to 20. The second section is concerned with additional controls, especially over the window function that's applied to all the grains and the source audio data. So let's have a look first at the different types of windows we have available. Here in the selector, the user can choose between 4 types of windows and use them to further shape the envelope of the grains, where the hand window is pre-selected, and next to it we have a rendering of the current window function. So the hand window is well suited for granular synthesis, although it doesn't really allow for control of its parameters, which is why I've added the other ones. So say, for example, we want to achieve less attenuation of amplitudes at the beginning and end of the grains. So then we can select the 2-key window, which will update the window rendering. And we can then modify this window function by dragging this window modifier slider. And we see the result of our operation being transferred back from Bella, so we can actually see what's going on. The source audio data selector allows the user to change between the source material that's actually used for the extraction of the grain source buffer. So, for example, if I press song 2 here, you will see that this value has changed, and now it only goes up to 69 instead of, for the first song, it was 86. So we can actually modify the source audio data that we use for synthesis, and that works even during playback. The third section then is concerned with filtering the sound globally. So in the filter section, we have access to 2 filters parameters. First, 4th order low pass filter, which was adapted from the implementation from the first assignment in music and audio programming. And the controls are pretty straightforward. We can control its cutoff value in hertz and its quality value. And then I've also added a high pass filter, which can be useful to trim some of the low frequency content, especially when playing lower notes, due to the depending on the window we use for grains, especially with lower notes, that can sometimes lead to clicks, which we can kind of attenuate by adjusting the cutoff frequency of the high pass filter. To demonstrate the system's performative capabilities and live capabilities, I've created this rather complicated live setup where my audio interface is connected to my notebook, my microphone is connected to my audio interface, this little speaker is connected to Bella, this MIDI keyboard is connected to Bella, so the microphone takes the output of Bella through the little speaker into my audio interface, back into my notebook, so we can listen to how this sounds in higher quality. So first we're going to look at what happens if we change the number of grains per second, so the grain frequency for each voice. And you can hear the repetitive kind of nature. And next we're going to increase the grain length. So then if we select a different window, we can radically change the sound that's coming out of the grains. Especially if we use the Gaussian window with a low modifier value. The trapezoidal window can be used to kind of dim down the sound a bit. But for now, let's keep it at the Gaussian window. And then let's increase the grain length a little bit and change the source position. So you can hear that the sounds that are coming out are completely different, and it changes even more if you change the actual source material. So now let's try the scatter option. And you can hear that the starting positions and also the length of grains are changed pseudo-randomly, so you get this kind of sonic texture coming out, which can be used to create kind of soundscapes. Let's change the source position once more. And try out the filters. So if we decrease the cutoff frequency, you can hear that it takes away the high frequencies, increase the Q a little bit, and make a fade out effect by increasing the cutoff frequency of the high pass filter. Yeah, that's it for the presentation in terms of the real-time performative capabilities. I hope you've enjoyed this video, and I hope that explained what my system actually does.